Good morning. In our last video, we had talked about uh, binary operations and some properties of binary operations like associative operations, commutative operations, closure operation, and we had also discussed the identity element. In this lecture, we're going to talk about the inverse element. We're going to talk about the inverse element. So what is the inverse element? So S is a non-empty set. S will have some values, and star is a binary operation. Star is a binary operation. Now let star be such that for every A, for each A belongs to G, there exists a B belongs to G, such that A asterisk B is equal to B asterisk A is equal to the identity element, right? Then B is the inverse of A. Okay, and it is denoted by B is equal to A inverse. This also implies that A is equal to B inverse. In other words, the inverse of B is A. Okay, now example, right? Say S is the set of all matrices. S is set of all matrices. So we take the operation, binary operation, to be the matrix addition. So say B. So say A belongs to S, then there will be a matrix B equal to minus of A, which belongs to S, and B plus A will be the zero matrix. Hence B is the inverse of A. We take another set. We take the set of integers I, okay, and A belongs to I, then B equal to minus A belongs to I, or B plus A equals to 0, which is the identity element of I, and hence B is the inverse of A. So now that we have discussed the kind of binary operations, the different types of binary operations, we come to something called the algebraic structures. Algebraic structures. So what is an algebraic structure? So G is a non-empty set. G is a non-empty set. So G is not equal to, or G is not equal to the null set. And there is a binary operation star, then G and an asterisk taken together, G and star taken together, is an algebraic structure. Okay, now so you have two elements in G, say A, B, right? And A binary operation with B also belongs to G. So which property holds? The closure property holds. The closure property holds. Right? So since the closure property holds, G star, this is an algebraic structure, and it has a special name. The special name is groupoid. It's called a groupoid, right? So you have to remember this name, it's important. So set of natural numbers taken with the binary operation plus, the set of integers taken with the binary operation plus, are groupoids. Okay. Next. So this is an algebraic structure, and A, B, C are three elements of G, and A star B within bracket B star C is equal to within bracket A star B star C. So this is what? This is associative property. This is one property. The second property is A star B belongs to G for all A, B belongs to G. So this is the closure property. So when 1 and 2 hold, this algebraic structure G star is a semigroup. It is a semigroup. a set of integers plus and the set of integers multiplication are examples of semi-groups. Okay. Now, what about this? Is it a semi-group? Is this a semi-group? So we have to check two things. One is, does take three numbers, 1, 2, and 3. So does closure hold? Closure 1 minus 2 belongs to I. 2 minus 3 belongs to I. 1 minus 3 also belongs to I. Closure holds. Does associativity holds? Associativity holds. 1 minus 2 minus 3 equals to what? 1 minus 1 is equal to 2, and within parentheses 1 minus 2 minus 3 is equal to minus 1 minus 3, which is minus 4. So this does not hold. This is A, this is B. A is not equal to B, hence it is not associative. Thus, is not a semigroup. The next thing that we have is this algebraic structure G star is one semigroup and two E belongs to G. So this has an identity element. So this kind of algebraic structure is called a monoid. A monoid. Okay? M-O-N-O-I-D, monoid. So I plus is a monoid. As we know, it is a semigroup, and it has an identity element E. In this case, E is 0. I dot is a monoid. In this case, E is 1. Okay. Okay. So says G star is a monoid. This is the first property. The second property is say A belongs to G, then A inverse also belongs to G. These two hold, they both hold, then what you have is G star is a group. This is a group, right? Next, say G star is a group. This is the property 1. Property 2 is A, B belongs to G. We have A star B is equal to B star A for all A, B belongs to G. Then this is called an abelian or commutative group. In other words, if each and every element A and B in G with respect to this binary operation star commute with each other, then it is an abelian or commutative group. Thank you.